In this video, we're going to extend our coin flipping program. And we're going to adapt it. Now, instead of flipping a coin this time, I want to actually roll a dice. So, if we have a six-sided dice, I'm going to need to not just have heads and tails. I'm going to have to actually change this. So I'm going to change my heads to 1. So I'm going to Control F. I'm going to replace heads with 1s. And I'm going to replace tails with 2s. So now I've got my 1s and 2s. But I'm going to need to make more variables now. I'm going to have to make 3s equals 0, init 4s equals 0, init 5s equals 0, init 6s equals 0. Okay, it's getting a bit annoying now, and then we have to go down here, and we have to make 6 of these statements, and then 6 of this is a bit annoying. And actually, you know, I've got a friend, and my friend's really into Dungeons and Dragons, and sometimes he has to roll a 20-sided dice. So if I continued this way, I'm going to have a variable called 7s, 8s, 9s, 10s, 11s, 12s, 13s, right up to 20. I'm going to have 20 variables, 20 statements, and 20 down here. It's going to be a really long program, and that's a lot of work. Maybe there's a better way we could do this. Maybe we can find a way to change this so we can have any number of objects that get chosen randomly and keep a track of how many have been selected. So instead of having like 20 variables, wouldn't it be nice just to have like one variable? And that variable could hold any number. So what we're going to do is we're actually not going to use an individual variable like this. We're going to create a list. And in that list is going to have like 20 spots. And we can just reference each item on that list. So we're going to create something called an array. Okay? So we're going to create a variable called list. And the list is going to be a new array. Okay? Now just capitalize that to make it clear, but we'll just write array. And how big is our array going to be? Well, we don't know, because we might change it. Sometimes we might want a 6-sided dice. Sometimes we might want a 20-sided dice. So we need to have some type of variable to hold the size of this array. So init size equals 20. Now when we create our array here, we need to give it a size. We are going to give it a size. You don't actually need to give it a size. You can just add things to it later on, but we're actually going to give it a fixed size. Now let's just talk about this array. When you have an array, the way it works is the first box. It's like creating 20 boxes. So I'm just going to use this to symbolize a box. And so on and so forth. Now the first box, it's going to be given an address of 0. And the second one is going to get an address of 1, and then 2, and then so on. And the last one, in this instance, because there's 20, is going to get an address of 19. It's going to get an address of 19. So 0 to 19 plus 1 makes 20. So those items are going to be the 0 through to the 19th element. So now we have this array, and it's much easier to manage than having 20 or 6 or 15 variables, however many we need to deal with. So now we've got this, let's deal with what happens in this loop. So we want to keep the loop, and we want to keep this number of trials. Now we need to change this random number to generate a random number that's not 0 or 1. It's between 0 and 19. Because remember, our array is going to have 20 elements, so it's going to be between 0, 19, and they have to be integers. The next thing we need to do is we need to increase the value of whatever random number we select. So if we select box number 1, we need to increase the value of box number 1 by 1. So we're going to say increase our list at element random number. So if that's a 1, it's going to be element number 1 by 1. And that's all we need to do in here. It's much simpler. And down here at the bottom, well, we're not going to do individual statements. We're just going to put them in a loop again, because we might have 20 of them. So for record equals 0 to 19, we're going to print our list at whatever record number we're at. Next, record. And that's our pseudocode. And that will do a much better job than having 20 variables. It's much more efficient, much easier to read, much easier to debug, much easier to manage. Now what's the hardest thing we have to do here? It's this random number thing here. So at the moment we have this line for our random number. So if I just execute that, it's going to give me a random number between 0 or 1. Now what's the important part here? The important part is this math random. Because math random, it chooses a number between 0 and 1, but we want to choose a number between 0 and 20. So if we just multiply that random number by 20, it will scale it or stretch it to fill that domain. So if I could just go math.random times 20, and now it's giving me a random number between 0 and upper bound of 20. And if I round that, it will give it that to me as an integer, which is exactly what I want. So now I can come over here and I can adjust the code over here to match the pseudocode that I have here. So the first thing I need to do is I need to create a variable called size. So we'll get rid of heads and we'll call it size. We'll set that to 20. The next line we initialize something called a list. And the list is going to be an array of a certain size. So we have to go new array with this size. Now if we just do this, it's going to create a list with 20 elements, but those elements are going to be undefined. So it's not going to know what they are. So we're going to set all those elements to 0 to start with. So .fill 0. So this will now create a list with 20 elements, and each of those elements will be 0. We'll keep the variable max trials. We'll keep this trials loop. Our random number here just has to be multiplied by 20 times 20. Now this part here we can get rid of. And we need to just address whichever item is selected. So we can go list the random number element, and that's going to equal whatever that currently is, plus 1. And down here, instead of individual console log statements, I'm just going to put a loop around this. So for let record equals 0, while record is less than 20, so not 20, but less than, record equals record plus 1. I don't know what I did there. There we go. Just hit the wrong key. Doing that a lot today. Okay, now what am I console logging? I'm going to console log the value of whatever record I am at. I'll put a semicolon in. And it's going to be, it's not heads, it's going to be list record. Okay, then I run. And I've got my result, so let's have a look. Now there's 20 values. If it's evenly distributed, they should all be around 5%, give or take. So I've got 2% here, but close to 5, close to 5. They're all reasonably close to 5 apart from the 0th element. Okay, and that's with 10,000 trials. So let's just go straight to 1,000,000. I'll save that. And 1,000,000 trials, I get the same thing. And now I'm getting this anomaly here. So let's just try 10 million and see if that is consistent. Alright, so I'm getting an anomaly. The 0th value is only coming up half the number of times that I would expect. So there's obviously a bug in our program. Let's investigate. So what I'm going to do, I'm going to decrease the number of trials to 100. And what I'm going to do, I'm actually going to print out the random number. Console.log random number. Okay, I'll run this. Now this is giving me all the random numbers that have come up. Oh, there's a 20 in there. Ah, right. So 20 is not getting recorded, so that's my other 2.5%. That's probably because I'm using a round function. So instead of round, what I'm going to do is going to do floor. Now the floor function basically rounds down regardless. So sometimes I must be getting like 19.7 and that's rounding up to 20. So if I do a floor, that 19.7 is going to round down to 20. Okay, so I'll save all this and I'll run again. And 0 looks much better. I'll go back up to 1,000,000 trials. And 1,000,000 trials, and there we go. They're all around 5%, which is what we would expect and what we would want. So there we go. We have successfully created a random number generator. And we can count and keep track of how many times each value appears. So statistically, we could take this data and we could create like a bar chart. And we could verify visually how this data is generated and what values we are getting.